All right, this is part 2 of that section, complements and unions of events, number 6, which is really number 19 in the book. And in number 19 in the book, they give us age categories and also the number of workers in thousands that are working below the minimum wage in that age category. So, for example, between the 16 and 19 age group, 329,000 were working below the minimum wage. And it says, if we select a worker randomly from those surveyed, what is the probability the person is younger than 55? So we have all these workers, and we're asking for the probability they're younger than 55. Okay. Well, in this case, I think it might be easier to calculate the probability that they're older than 55, or 55 or older. And so we'll use the complement rule again. So I'm just going to find the probability they're 55 or older because I think that's a little bit easier. Because notice in that case it only involves adding up two numbers as opposed to a lot more. So let's see. But it looks like the number of people that are 55 or older is 61 plus 53. But we also have to take into account the total number of people in the chart. And I'm not sure they give us in the problem that number, so I'm going to have to sum up that number myself. And I'm talking about the sum of all the people in the chart. That would be the sample space, essentially. So let me do that with a calculator. And I get this, 1483. And remember, this is just the probability of the complement. The probability the person is 55 or older. So let me plug all that into a calculator. And I get 0.9231. Or if I wanted to round to the nearest thousandth, then it would just be 0.923. So let's move on to the next one, which is number 7. That one's a little trickier, and it also involves a chart, which I went ahead and wrote down for you, so you wouldn't have to wait 5 minutes watching me write it down. But let's read the problem. It says, what is the probability that a consumer we randomly choose either spends 0 to 2 hours per month shopping on the internet or has an annual income below 40,000. All right, so notice that either or phrase, that probably means that we're going to need the rule for the probability of the union of two events, just because of the or. So let me read it again. It says, what is the probability that the person either spends 0 to 2 hours per month shopping on the internet or has an annual income below 40,000? So let me use some mathematical notation to abbreviate that. So we're looking for the probability they spend between 0 and 2 hours per month shopping on the internet or has an annual income below 40,000. And I'm going to represent that event with a B. So notice that I'm going to use the rule for the probability of the union of two events. It's the probability of the first one plus the probability of the second one minus the probability of the intersection. So the notation there is a little bit awkward, but I think you understand. Well, let's find the probability that they spend between 0 and 2 hours per month on the internet. Here's what you do. Take a look at the 0 to 2 hours column. There are a total of 544 people out of 1,600 that spend between 0 and 2 hours per month on the internet. So the first probability is 544 over 1,600. All right. Now let's calculate the probability that they make less than 40,000 per year. So let's go back to the chart. Well, notice that you need to look at the below 40,000 row, and it looks like there are a total of 592 people out of 1,600 that make below 40,000 per year. So the probability of that is 592 out of 1600. All right. Now let's find the probability the person is on the internet between 0 and 2 hours per month and makes below 40,000 per year. Well, here what you have to do is find the number that is in the intersection of this row and this column. So it looks like there are 272 people out of 1,600 that make below 40,000 per year and at the same time shop on the internet between 0 and 2 hours per month. So the last probability is a little bit tricky. You have to find the number that's in the intersection of this row and this column, and you'll probably have to do something similar in the homework. Well, the probability is just 272 over 1,600. So I'm going to plug all that into a calculator. And I get 0.54. All right. So a little bit trickier, I think, than number 6, but let's move on to number 8. And it looks like that's number 31 in the book. It says, your car's windshield wipers have not been working properly. The probability that you need a new motor is 0.55. So let me stop there and write down that probability that I need a new motor. The probability that we need a new switch is 0.4. And the probability that you need both is 0.15. So how do we represent both? Well, that means motor and switch. So I use that intersection symbol once again for the word and. Both kind of implies the intersection, motor and switch. What is the probability that you need neither a new motor nor a new switch? Well, in this case, it might actually be easier to find the probability that we need either a motor or a switch. And then to calculate neither, I'm just going to subtract that probability from 1. Because neither one is the complement of one or the other. And that's a little bit confusing. But in this case, I think we want to find the probability of the union first. And then I'll just subtract that from 1 to get the probability that it needs neither one. So use the union rule again. And just plug in the numbers that they gave us. So probability of M is 0.55. Probability of S is 0.40. The probability of both is 0.15. So let's plug all that into a calculator. And I get 0.8. All right. But remember, we're actually looking for the probability that it needs neither one. And that is the complement of one or the other. So I really just have to subtract that from 1. And I think I can do that in my head. So the actual answer is 0.2, believe it or not. Just take 1 minus 0.8 for your answer. Let's move on to number 9. And that's number 37 in the book. A manufacturer, this one's kind of tricky. A manufacturer has shipped 40 flip cameras to a Great Buy store, of which 6 are defective. So 40 total, 6 defective. If Great Buy sold 18 cameras before discovering that some were defective, what is the probability that at least one defective camera was sold? So we have 18 that were sold out of the 40. And by the way, they give us a little hint here, but it says, what is the probability that at least one defective camera was sold? All right. Now, this is a good example of a problem where it's easier to find the probability of the complement. So, what is the complement of at least 1? It is none. So, I really just have to find 1 minus the probability that no defective cameras were sold. All right. And that's the tricky part. That's where they give us a nice little hint in the problem, and I think you get one on the online homework too. So let's see if we can figure that out. All right. Now here's the idea. There were 40 total cameras. 6 were defective. Doesn't that mean that 34 cameras are perfectly good? And if we say that we're looking for the probability that no defective cameras were sold, that means all of them that were sold were good. So what you have to do is count the number of ways to sell only good cameras. Well, we just said that there were 34 good ones, and we sold 18 of them. So believe it or not, 34 choose 18 is the total number of ways that we could have sold only good cameras. But we also have to divide that by the number of outcomes in the sample space, or the number of ways that we could have sold the cameras in general. Well, remember, we had 40 total cameras, and we sold 18 of them. So that is actually the total number of ways that we could have sold the cameras in general. And that is part of the hint in the problem. But we probably could have done it without the hint. And this part is a little bit tricky to plug into a calculator, but let's go ahead and do it. So I get 0.981, and that looks correct. So certainly a little bit trickier and difficult than some of the other ones we've done, but we do have one more problem on this video to do. And this one is also a little bit tricky. It's actually very similar to number 9. Let's read it first. Number 39 in the book. The sashimi restaurant has prepared 18 portions of seafood, 2 of which have been left out too long and spoiled. If 12 of the 18 portions are served randomly to customers, what is the probability that at least one customer will receive spoiled food? And the hint is to consider the complement of the event. So very similar to the last problem. Well, let's write down the information. We have 18 portions total. Okay. And 2 of them are spoiled. But we're going to serve 12 to customers. That's the information in the problem. But what are we being asked to find? It says, what is the probability that at least one customer will receive spoiled food? So let's see. Now, once again, you see that phrase, at least one. Usually it is better to find the probability of the complement and subtract it from 1. Because it is usually easier to find the probability that no customers get bad food than it is to find the probability that at least one does. So I'm just going to calculate 1 minus the probability that no customer gets bad food. All right. So very similar to the last problem, it's going to be a ratio of 2 combinations. So let's see if we can figure it out. Well, if no customer gets bad food, then they all got good food. So let's calculate the number of portions that are actually good. Well, 18 total, 2 were spoiled. That means 16 portions are good. But we're going to serve 12 of them. So 16 choose 12 is the total number of ways for us to have chosen only good portions. But what is the size of the sample space in that case? Well, we have 18 total, and we serve 12. So it sounds like 18 choose 12 combinations is the total number of ways that we could have chosen the portions to serve to the customers. So let's plug all that into a calculator. And I get 0.902. So it's pretty likely at least one customer got bad food. So we're 90% sure we're going to get a complaint there. But that's enough for that video.